Yes, let's look at this question number 13 for JAMB Past Question Chemistry 2018. Suitable reagents for the laboratory preparation of nitrogen are A. Sodium dioxynitrate 3 and ammonium chloride, B. Sodium trioxynitrate 5 and ammonium chloride, C. Sodium chloride and ammonium trioxynitrate 5, D. Sodium chloride and ammonium dioxynitrate 3. So what is the correct answer? Now if you check the textbook, chemistry textbook for under nitrogen and its compounds, you will note that the laboratory preparation of nitrogen is actually from, there is laboratory preparation of nitrogen from ammonium dioxynitrate 3. So how do we come about this? So like I said, this is the lab preparation for nitrogen. Laboratory preparation for nitrogen from ammonium dioxynitrate 3. But how does this happen? This actually happens by using a mixture of sodium dioxynitrate 3 and ammonium chloride, and this mixture is actually done in the ratio of 7 is to 5, and this mixture is done what? It is heated to yield. Whenever you heat, when you heat this mixture, you will now yield ammonium dioxynitrate 3. This ammonium dioxynitrate 3 in turn decomposes to produce nitrogen and steam. So you see the way nitrogen is produced from ammonium dioxynitrate 3. But how does this ammonium dioxynitrate 3 come to be? By having a mixture of sodium dioxynitrate 3 and ammonium chloride. That's how you produce this. So once you have a mixture of sodium dioxynitrate 3 and ammonium chloride, you produce ammonium dioxynitrate 3, which can easily decompose on heating to produce nitrogen. So you can see here we have sodium dioxynitrate 3 and ammonium chloride, and that makes option A the right answer, because the mixture of sodium dioxynitrate 3 and ammonium chloride in the ratio of 7 is to 5 produces ammonium dioxynitrate 3, which decomposes upon heating, or which decomposes to give nitrogen and steam. So that is the laboratory preparation of nitrogen, and you can find this under nitrogen and its compound. So that's what happened. In terms of equation, you can actually have it as sodium dioxynitrate 3, which is actually aqueous, reacting with ammonium chloride, which is also aqueous, to form ammonium dioxynitrate 3, which is aqueous, and sodium chloride, which is also aqueous. So this very ammonium diosonitrate 3, this ammonium diosonitrate 3, which is aqueous, then further decomposes to nitrogen, which is what you're looking for, gas, plus your steam through H2O, which is liquid. So that's how you get about the laboratory preparation of nitrogen. Thank you. Hello, welcome. Let's look at this question number 12 for JAMB Past Question Chemistry 2018. A quantity of electricity liberates 3.6 grams of silver from its salt. What mass of aluminium will be liberated from its salt by the same quantity of electricity, given that aluminium is equal to 27 and silver is equal to 108? Option A, 2.7 gram, B, 1.2 gram, C, 0.9 gram, D, 0.3 gram. Now, whenever you want to solve the problem of electricity and the position of metals, first of all, you need to know the number of valence electron, or the number of electron needed for such action to occur. So let's say for silver, what do we have for silver? We are going to have silver is plus, so we are going to have one electron because it's just one valency. Then you have your normal silver. So once there is this, you have the deposition of your silver, just one electron, so 1 mole of electron in this case. But in aluminium, what do we have? Aluminium has 3 valence electrons, so we have aluminium 3 plus, so we actually have 3 moles of electrons in order for us to get our normal deposition of, or get our aluminium liberated. So if you want to liberate silver, you have just 1 mole of this, 1 electron, 1 mole of electron. Here we have 3 to liberate aluminium. So how do you go about solving this? So for the first one, where we have silver, we have the 1 mole of electrons. 1 mole of electrons liberates how many? It actually liberates 108 of silver. This is where we got the 108. So if 1 mole liberates 108, now how many moles, x moles, will liberate 3.6? So the quantity of this electricity we are talking about is actually x mole. So you have 1 mole liberating 108, x mole will liberate 3.6. So make x the subject of the formula. You have x to be equal to, you cross multiply, x to be equal to 3.6 all over 108, and this will give you 0.033. So if you do 3.6 over 108, you have 0.033. So this is the quantity of electricity that we are talking about. So this quantity of electricity, how many gram of aluminium will it give? But from this our initial equation, we can see that 3 moles is actually 3 moles because of these 3. For silver it was 1 mole because here is 1. So for this aluminium, 3 moles of electrons is going to liberate how many? It's going to liberate 27. You know, here it was 108 because it's silver, but for this we have 27. So 3 more will liberate 27. Now the same quantity of electricity, which is what, 0.033 as we have here, will now liberate what gram? X gram of aluminium. So if you make S gram the subject of the formula and you cross multiply, you're going to have that you're going to have X gram to be equal to 0.033 times 27 all over 3. That's when you cross multiply. you have 0.033 times 27 all over 3 mole. So if you do this calculation, what are you going to get when you press the calculator? If you press your calculator and you say 0.033 times 27, which is going to give us 0.891, divided by 3, it will now give us 0.297. So if you make this calculation, 0.033 times 27 all over 3, what are you going to get? You're going to get 0.297. So this is the mass that will be liberated, 0.297, and this 0.297 is approximately equal to 0.3, because this is 9, so you can approximate this to 0.3 gram. So the right option is going to be D, 0.3 grams. So note the way we calculate this: number of moles of electrons needed to liberate this, you already know by checking the valence electrons. So it actually gives what you have here, the number of moles you have from the normal equation, gives you the amount here for the atomic mass. So that is how you go about solving this. So take note of this, then do the appropriate substitutions, and you get the correct answer. Thank you.